Perfect. Thank you, Amrut. Okay, thanks a lot, everyone. So let's come back. Okay, let's have a quick recap of what we have spoken earlier. So, folks, from the last session, so what you have learned is you have learned that when we talk about the Kubernetes, it is basically an orchestrator. It will help us to orchestrate the containers. So that's what we are aware of. Now, that's what we have learned in the last session. Now, to give you a quick recap, what we'll do in the case of Kubernetes is, as a developer, we'll create an application, we'll package it as a container, and then we'll provide this container to the Kubernetes. And once we provide this to the Kubernetes, we'll have the Kubernetes cluster. This Kubernetes cluster is made up of control plane nodes and the worker node, and the control plane nodes implements the cluster intelligence, and the worker plane uh, or the worker node is the one which where my applications would run. So basically, we'll design and write the application as a small independent microservice in our own favorite language. We'll package this microservice as its own container, and we'll describe the requirement in a configuration file, and we will post them to the Kubernetes. Now, while posting it inside the Kubernetes, we'll not directly post it. We are going to wrap our container inside what we call it as a pod is an object inside the Kubernetes. And we'll not simply deploy the pod, we'll be wrapping this pod around high level controllers like deployments, daemon sets, cron jobs. Depending on our requirement, we will be actually creating a wrapper around it. So then we'll be sending this wrapper to our Kubernetes. That's the overall idea, and from where the resources gets created. And as I've mentioned, we've got various components inside our Kubernetes. We've got control plane, worker nodes. This we have talked about it in our last session. So we had already about it. So the main that we had to do from the last session was basically the hands-on. So let's go ahead and perform the hands-on. For the demonstration of the same, got the code created, and I'll be sharing with you as well, folks. So to get started, first thing that we would require is we need to have a Kubernetes setup. So there are very easiest ways to get it. So as I've described in the last session as well, you can install the Docker. And once you install the Docker, so you can enable the Kubernetes add-on from the Docker itself. So to give you an example, so I have installed the Docker over here. I'll go to the extensions, and you can actually, yeah, you can under the settings, you can enable the Kubernetes. So that would actually give you a setup where you'll have a single control plane, and the same control plane will be working as a worker node. Okay, that's not an ideal situation that you'll have in a production environment, but this is what you can set up for the practice for learning purpose. Alternatively, what you can do is you can of the Google Cloud or any other environment. Let me just give you an example. So I'll show you the other example as well. So what you can do is you can create an account with Google, and from here, just you can launch the Kubernetes engine. This is called in Google, it's known as Google Kubernetes engine, which is one of the managed service by Google Cloud. So you can make use of the same, and you can create the cluster from here as well. Okay, so for the demonstration purpose, I want to give you a quick hands on how you can do it. Just click on create button in the Kubernetes cluster. You will have basically have two ways, like one is a standard mode and the autopilot mode. So to get started, you can click on configure under the standard mode, and you can create a Kubernetes cluster by manually specifying how does your control plane would look like and how many number of worker nodes do you want. In my case, I've already created it. I've created a control plane. You can name your cluster, and then under the node pool you can mention the name for the node pool. That means how many number of worker nodes you want. By default it is mentioned as 3, so you can click on create button. This would actually go ahead and create a Kubernetes cluster. I've already created a Kubernetes cluster, and if I take you to the compute engine page of my Google Cloud, you'll be able to see that there are, yeah, these 3 virtual machine that you're running that you see right here. So these are basically my Kubernetes worker node. Okay, so these are basically my Kubernetes worker node, which is attached to my Kubernetes cluster, that is my cluster 1. Now, once that is done, you can click on connect and connect to this Kubernetes cluster from your terminal. So let me bring up my terminal screen. Okay, so I'll just run the commands and this would connect to my Kubernetes cluster. So I am now connected to this Kubernetes cluster, which is running on my Google Cloud. Now to get started, so let's start with the very basics about what exactly is a pod and how do we actually create a pod inside a Kubernetes. Now, when we talk about this pod inside the Kubernetes, as I mentioned already, guys, see, about so when we talk about the pod inside the Kubernetes, so pod is a smallest unit, okay? It's a smallest unit whenever you are working with the Kubernetes team. Okay, so what I mentioned, so pod is basically a wrapper around our containers. Suppose this is a container that I've got. Now this container is something where I have my application. Let's suppose this is a container that I've created, which is my nginx container. Then what you can see is my pod is basically a wrapper around this container. We'll not directly use the container as it is, so we want to give some additional ability for my container. That's the reason that I will be wrapping my container around a pod. Now, what are the additional things that we generally specify where we are creating the pod? We can give it as name. Okay, we can add any metadata for identify the multiple container. I can do it, and this would be the additional high level details that I'll be able to add it when I'm wrapping my container inside a pod. Okay, now how does the communication would happen whenever we are working? So first thing that I mentioned is when we start working with the Kubernetes, we'll have a master node and we also have the worker node. So let me just give you an illustration as how it actually happens. So let's say this is my node 1, I worker node 1, and I'll have my node 2. This will be my worker node 2. In the same way, let's say I will have my worker node 3. So basically, I have three worker nodes in this example, just like I've shown you earlier. And along with that, I'll also have the master. Okay, so let me just bring up a master. Yeah, I'll have a Kubernetes master. So this is my master or the control plane. Now, I have mentioned that the pod is a basic object that will be working inside the Kubernetes. Now, how do I actually deploy the pod inside my Kubernetes cluster? Now, if I decide that I want to deploy something inside my Kubernetes cluster, first thing that we have to do is I'll have to create a YAML file, which we call it as a YAML manifest. I'll create a YAML manifest. And once I create this YAML manifest is nothing but it's a YAML file which contains all the instructions for my Kubernetes to create the object for pod, since that's the object that we are talking about. Now, once I create this YAML manifest, I'll be sending this YAML file to my control plane. How do I send it? In order to send the same, I'll make use of a command line interface, which we call it as kubectl. So let me mention. So using my kubectl, which is my command line interface, using this, I'll be sending this YAML manifest file to the control plane or the master node. Okay, that is what I'll be sending. Now to which part that I'll be sending? Well, I'll be actually sending it to the control plane. This is correct, but there will be an important part inside my control plane which is called as API server. Okay, we have something called as an API server. For the API server, we are going to send this information. Okay, I'll be sending this YAML manifest file right here. You can think of it in this way. So this is part of my worker node. So this API server is one of the component inside my control plane. Okay, so so I'll be sending this information to my API server. Now this API server, what it does is it will interact with the other components inside my control plane. So what it will do is API server will go ahead and talk to the scheduler. So this is basically my scheduler. Now scheduler, it will talk to the scheduler and say that, hey, I've received a new request for creation of pod. Why don't you go ahead and let me know where can I actually go ahead and create this incoming object of creation of pod. Now this scheduler, it will refer to my YAML file, look into the configuration that is mentioned. If I mentioned some settings, it would go ahead and validate whether the matching node is available with me or not. Let us assume that I'm deploying a deep learning application. As you know, when we think about deep learning, I'll be requiring a powerful GPU, a node which contains the powerful GPU. Now, in such scenarios, the scheduler look into the details of my pod manifest and check, okay, it is requiring a system which has the GPU. Then the scheduler will identify which node is the one that it's going to select, at least which is the one that the resources are matching. Then once it decides, okay, this is the one that it has to match, so it will update a table that is called as HCD. Okay, it would update the HCD. So this is my HCD component, which is basically a key value pair. Key values will be stored of my Kubernetes. You can think of it as a place where everything is stored about my Kubernetes cluster. It will update my HCD, and this API server will communicate to the scheduler. That's what I've mentioned right now. Now, once this is done, okay, the API server got to know that, okay, node 1 is the one, it has to schedule the pod. So what it will do, it will inform the node 1. It will inform the node 1. Obviously, it cannot talk to the computer. So there are other components which will actually help us to do that. Let me just give you an illustration of what are the components that it will talk to inside the worker node. So inside the worker node, if I'll call it as node 1 here, so basically what it will do is it will inform a Kubernetes component which is called as a kubelet. So the API server will inform the kubelet saying that, hey, I've got a request to create a pod from my YAML manifest file. You can go ahead and use this file and create the pod. So the kubelet is the one which receives the information from the API server. Say that create pod. Okay, now once kubelet receives it, it will then go ahead and create the resources inside that node. Like that is when I'll go ahead and create a pod. So I would now go ahead and create a pod right here. So I would go ahead and create a pod in that particular node. Now, once I've scheduled the pod, this kubelet will then go ahead and inform the API server saying that, okay, so I've actually done the task. So I've created the pod. Now, this information will be made available to the user whenever I'm talking to this Kubernetes cluster with the help of kubectl. So that's the idea of deploying the pod. Okay, are you with me till here, guys? So please confirm in the chat window. Is this concept clear at a very high level? Any question? If you're clear, please confirm by typing as all good. Okay, thank you, Darshan, Samiksha. Okay, Prakash. Okay, I see a few more confirmation coming in on the other live group that we have got. Samir, perfect. Thank you so much, guys, for confirming. So now that you are aware of the complete story of how it actually works, let's have a high level idea as how it actually works. Let's take up a YAML manifest file and let's see how it actually look like. And let us understand, okay, let us understand how do we actually write it. Okay, and then we could go ahead and then we can go ahead and work with the same. Okay, So that's the overall idea. So let's proceed ahead and understand how we can actually write. So this is an example I want to show you. So this file is called as pod.yaml file. So at the end of the session, I'll be sharing you all these files. Don't worry. For now, just be with me. Okay. So if you look into this file, basically it is the file with YAML extension. And here, this file, inside this file, there are four important mandatory things that we have to specify whenever we are creating the resources. So API version, kind, metadata, and spec. So these are the four mandatory elements that we have to specify when we are creating the Kubernetes manifest file. So let's start with API version. API version for the pod resource is v1 and the kind is pod, and under the metadata, the important metadata which is mandatory is the name. Here in this case, I have mentioned as first pod. Okay, and we can also add some custom labels as well. So in this case, I mentioned the labels as zone prod, version v1, project cat gif, and application v1. So these are all the custom labels. There is no mandate that this is mandatory. I mean, there's no rule that we have to always mention, but it is recommended. It will be used depending on our use case. And we also have spec. Under the spec, we would mention the specification of our container. Like in this case, I'm making use of the image which we have built, that is cat gif v1. It is a Docker container, and I'm mentioning my name as example container. Image pull policy is always, and the container port that I want to refer to as 5000. Okay, this is how my pod.yaml file would look like. Okay, so we've created this pod.yaml file. Now let's use this pod.yaml file. Let us create the pod, and then I'll give you an important information as how I have come up with this structure. Okay, so let's go ahead and do that. So since I have already connected my command line interface to this Kubernetes cluster that we are running, okay, let me just go ahead and deploy this pod onto my Kubernetes cluster. Now, in order to create the pod on my Kubernetes cluster, or in order to apply any YAML manifest file into our Kubernetes cluster, as I mentioned, we'll be making use of kubectl, which is my command line interface. I'll say kubectl apply -f followed by the file name. -f means file. Okay, apply the file of pod.yaml file. I'll press the enter key, and you should be able to see a response saying that first pod has been created. So the resource is pod and the resource name is pod has been created. So what has actually happened? So let me just give you a quick idea. So what I did, I had my YAML manifest file, that is pod.yaml file. I had made use of the command. What is the command that I've used? It is kubectl apply -f followed by pod.yaml file. Now, when I send this request using my kubectl command line interface, this communication connected to my API server. Now, this API server spoke to the scheduler, and the scheduler identified as to which node, that is my worker node, it has to schedule. And then it has actually created the pod with the help of the kubelet service, which is running inside my worker nodes. So let us go ahead and validate it whether my pod has been created or not. Now, if I want to display the node, that means what are the nodes that are part of my Kubernetes cluster, I can simply make use of the command kubectl get nodes. So this will show what are the nodes that are available inside this Kubernetes cluster. I've got 3 worker nodes that are attached to my Kubernetes cluster, and I can see right here, isn't it? Like there is cluster 1, node 1, node 2, and node 3. These are the 3 worker nodes that is running right here. Okay, now I've mentioned that when I enter this command of kubectl apply, it has deployed my pod on one of these nodes. So let's go ahead and do that. So if I want to display the nodes, kubectl. So get pods. Okay, we'll display the pod now. Get pods. It will say that there is a first pod that is created and it is currently in the running status. Now I'll say kubectl get pods hyphen o wide. So this will basically tell me where exactly is my actually has been running. So you can see that the first pod is running on my node. This is my node. Okay, my first pod is running on this node which is ending with jd64. That means I was able to successfully deploy my pod on one of the worker node. Okay, so what we have just did is we have deployed the pod into one of the worker node, and this is my internal IP address of my pod, which is that 10.104.2.1. So which means that we were able to create the pod. Okay, so we create the pod, and pod is the smallest unit which we'll be using whenever we are deploying our application. We'll be making use of pod, and this pod is basically a wrapper around our container, and we have now pod running inside our Kubernetes cluster on one of the worker node. Okay, that's what we have just did. Now the question is, can I see this application to validate whether it is actually running or not? So the question is, can I see this application to observe whether it is actually running or not? Well, it is possible. So, but here in the Kubernetes, it's not as straightforward as you would think. So, what we need to create is, if I want to access the pod, I'll have to create one more service, which we call it as the service itself. We call it as Kubernetes service. I'll have to create a service, which is another object inside the Kubernetes. I'll have to create this service object, and by creating this service object I can expose the pod that I'm running. Okay, I can expose the pod that I'm running to the outside world, which means this is the pod that I've created, and the pod name that we have just mentioned right now is the first pod. Okay, this is my first pod. Now if I want to ensure that this pod is accessible, I should be creating a service and I should be connecting my service to this pod. So I'll have to connect my service to this pod. So that is what I need to do, so that i can I can go ahead and I can go ahead and be able to access my pod from the outside world. Okay, so that's the overall idea of the service. Let me try to compress a bit so that you'll have everything in a single view. Yeah, so I should create a service so that I'll be able to access this pod from the outside world. Now this service is another Kubernetes object. Now let me just show you the YAML file of my service. So here there's a YAML file that I have created which is called as SVC Cloud. And if you look into it, the API version, kind, okay, and under the metadata and the spec. So API, kind, metadata, spec. These are the four components that we have to mention in our Kubernetes manifest file. And I've mentioned the same right here. And I've also mentioned how should I link it. So I'm saying that as create a new load balancer. On that load balancer, for the load balancer port of 80, connect that port to the port of 5000. Okay, connect to the target port of 5000, which is where my container is actually running. Okay, and to identify my pod, use the project as catgif. And if you look into the pod.yaml file, there was a label that I had created, that is project catgif. So because of this linkage, I'm able to say that to which pod that I want to create the service to. So now what I'll do is I'll create a new service. I'll say kubectl apply -f, okay, svc cloud.yaml file. So Now when I use this command of kubectl apply-svc cloud.yaml file, this will create a service for me. Okay, this will create a service. Now if I go ahead and say kubectl get service, so it will tell me that there's a new service that has been created for the load balancer. Okay, and let's wait. Currently the load balancer is getting created. And in the meantime, let's do one thing. Let's go to our Kubernetes cluster. I think it's waiting team. Let's wait for a minute. See, a load balancer, it is getting created. See, a load balancer actually has been created, and the backend is 3 instances. Okay, and you can actually check what are the instances for which load balancer is connected to. So it is connected to these 3 instances. Okay, that's what it clearly mentions. And what is the IP port? This is the IP port of 80. Now if I go to the IP address, okay, I should be able to reach the pod. I should be able to reach the pod. It has been serviced by first pod. So basically what I did was I created a service which is of the type load balancer, and this load balancer has its own IP address. Now I can go ahead and run the command again. So it will actually show us the IP which I had used earlier, and it is connected to one of the node port also, so which is taken care in the backend. We don't have to worry about it as of now. But yeah, if I visit this IP address, I'm able to reach the application which is running inside the pod. Okay, that's what I have done right now. So I'll show you the diagram again. So just observe this diagram and let me know if you have any questions. Now I'll take you through as how I have written this YAML file. But before we do that, just go through it and let me know if you have got any clear. Please confirm by typing as all good. Okay, I'll give you a quick a minute to just go through this diagram and let me know if you have got any questions, team. So if you're clear, please confirm by typing as all good. Sudeep says all good. Thank you, Sudeep. Samira says all good. Thank you, Samir. Hari says all good. Thank you, Hari. Okay. And Suresh is all good. Thank you, Suresh. Okay. Thank you, folks, for confirming. Now, let us understand how we can write this YAML manifest. Well, here to start with, let me bring up the pod.yaml file. So here I've mentioned the API version kind, right? So how do we get those value? Now, when we are working, there's a command that's called as kubectl API resources. So if I enter this command, this would basically list down all the various objects that we can create. This is the name. This is the shorthand notation. Okay, if I've got any, followed by the API version that I have to mention, and whether it is namespaced or not, and the kind. So in our case, we are working with the pod. So if I highlight that pod, if you observe, the short name is PO and the API version is V1. That means if I'm creating a YAML manifest, I'll have to make use of the API version as V1. Then The kind is pod, and remember this is case sensitive. That means you'll have to mention it in capital letter. I mean, it's whatever you see right here, you'll have to ensure that you follow the same casing, or else you'll get an error when you are working in the Kubernetes. Okay, so that's an important one. All right, folks. So we have mentioned the kind. Okay, uh, API version is v1 and short name is PO. So let's go ahead and do that, test that. So kubectl get PO. If I say kubectl get PO and if I simply press the enter key, it will give me the pod only. So kubectl and followed by, let me just display the enter the common commands. I've already added here. Let me just document itself so that it is easier for you. So I found this documentation from one of the website. You can actually refer to the same documentation by a website called Phoenix Snap. Okay, so you can actually see the various commands. Kubectl get pods. It will generate the list of all the pods that are running in. Okay, hyphen o wide detailed list of pod. That's what we have created earlier. And kubectl apply hyphen f. This will create a new service which is present in the YAML file. Okay, I can go ahead and do that. And then there are some shorthand notation that is also made. So you can also refer to this for a high level details as how you can work inside this Kubernetes. So we have made use of apply to create a resource, and we have made use of get to display. Okay, we had made use of get to display the resources, guys. Okay, that's what we can do right now. Okay, so we have looked into the implements, and we have seen how we have actually came up with this YAML manifest. So kind and API version is clear. Under the metadata, mandatory one is the name. Okay, rest everything are optional. Under the spec, we would specify the containers. So here I have mentioned that when I'm creating a pod is basically a wrapper around my container. Okay, so pod is basically a wrapper around my container. Now, depending on our requirement, we can actually have multiple containers which are running inside a same pod. Now, one of the simple use case that you can think about is whenever you're deploying your machine learning application. Okay, let us assume that you want to keep the data processing, that is, let's say data pre-processing, as well as the prediction. If you want to create both of them together, okay, both of them together running as a single pod, you can actually do that. So we call it as a multi-container pod. Okay, so to illustrate the same, this is how you can think about it. I can have a pod, so you can think of it as a pod, and inside this pod you can actually create two containers depending on your requirement. Like for example, this will be my one container and this will be the another container. Like one container will go ahead and perform the pre-processing of the data set, and the other container will run the prediction on the pre-processed data. So whatever the data that is received by the pod, that data will be reaching the container. Okay, that data will be reaching the container which does the pre-processing, and to communicate with the other pod, another container which is running in the same pod. So basically, it will make use of the local host. It will make use of the concept of local host to communicate with the other container which is part of the same job, like part of the same pod. So that's the idea of what you can think about when you're deploying a service, okay, which is an application where you want to have the data pre-processing and the prediction service to be tightly coupled, and that's when you will create it inside the same pod. Okay, now to illustrate the same, how does this YAML file would look like when you are having a multi-container pod? So I'll just give you an example. So here you can think of it in this way. So here, if you think about it, this is another YAML manifest file that I have created where the kind is pod, and the name is init container demo. That's the name that I've given. And here there is one container that I'm running, which is an nginx container. And under this spec, under container, one is nginx, and if you look into it, there's one more container that I'm running, that is alpine. So just to show you the example, I've just created multi-container inside the same pod. So now if I go ahead and apply this file, this would actually create a single pod with two containers running. That's how we can achieve a multi-container pod as part of our requirement. All right, guys. So this was about a high level idea as how you can work with the Kubernetes cluster and the components of the Kubernetes. And more importantly, we have looked into the idea as how I can create my pod and how to uh, get the pod once I've created, and how we can display the nodes. So those were the things that we have learned as part of a learning journey. Now, what I'll do is I'll create a new repository. So let me create a new repository, folks. And I would mention all the code that we have used into that repository. We have made use of pod.yaml file and svccloud.yaml file. I'll mention all those files over here in this repository. And I've also shown you the demonstration of this init pod. Okay, you can refer the same for your reference purpose. You can get the same from the repository. So this is the repository link. I'll be sharing you guys in the chat window. Okay, team. So do refer to this chat screen I've posted, so you can go ahead and refer to the same. So this is the URL that I've displayed on the screen as well. So github.com slash manifold AI learning slash Kubernetes 101 hands on. So under this repository, you'll be able to see all the files. Let's see, push. Okay, I believe it's a different one. Let's see. Oh, okay. Yeah, the commit was not complete. All right, folks. Okay. Now, one quick tip, team. So whenever you're working with the Kubernetes, so once you're done with the work, ensure you delete your Kubernetes cluster in order to avoid the building. All right. So this was what we had planned for today's session, folks. So as part of a learning journey today, you have seen make use of Kubernetes and deploy any application. So we have seen at a very high level how we can create the pod. Now, generally, we do not create it as a pod. We'll be creating it as a deployment, and we will be creating it as other like deployment and other controller objects, so that we'll be able to get the benefits like scaling, and we'll be able to get the benefits like healing, self healing. So those are the benefits that we would get if I'm working with the high level controllers of Kubernetes. So we'll try to include it in our future session. So before we dive into the hands-on of creating a CI/CD pipeline of machine learning and deploying it into the Kubernetes cluster. So that's what we are targeting as part of our future live sessions, folks. Now, this session was made possible with the team at Manifold AI Learning. So, folks, I just want to give you a quick information. So, there's a course by the team of Manifold AI Learning where I have authored, which is called as Master Practical MLOps for data scientists and DevOps on AWS. I highly recommend this course if you're someone who wants to understand the ML ops and take your learning journey of ML ops. So, this is the course that I would highly recommend for anyone who wants to begin their learning journey in ML ops with one of the most used cloud, that is AWS. Okay, I'll see you everyone on our next session. Now, if you're looking for best deal, so I would recommend you to visit the Manifold AI Learning site. So you can also get some best deal over there. So yeah, you can refer to the Manifold AI Learning site as well and use the coupon code email request. Okay, that's the coupon code that you can use it to get the super discount in the Manifold AI Learning page. Okay, I would leave it up to you guys, but thanks again for watching. And thanks again for joining in for this session and being so amazing and asking some of the amazing questions in our session. So if you have got any questions, do let me know. If you're clear, please confirm by typing as all good and feel free to drop. And I'll see you next time. The session recording will also be made available to you on the author's LinkedIn page, that is my LinkedIn page, as well as the YouTube channel of Manifold AI Learning. You can also get it there as well. Okay, so thanks again for joining in, and I'll see you next time. Take care.